Hi, my name is Steve. I'm with the Sensorica network. Thank you for watching the Sensorica channel again. In this particular video, we're going to talk about breathing games. We'll present a project, a pretty cool project that I'm working on right now, which is about prototyping some open source therapeutical devices for kids that suffer from cystic fibrosis. So if you go to the Sensorica website and use the search button here and type breathing or breathing games, it's about breathing, right? You're gonna find this project and you can know everything about it. A few words about breathing games. This is a community that has been around for 6-7 years now. At some point it has been incubated within the Sensorica lab in Montreal, where we have been prototyping these instruments, these devices with them. And also it's a little loud. And so you can go to the page and take a look at all these videos here if you want. Also some pretty cool presentations. So we have been incubating this project within the Sensorica lab for a while. Then apart from the technical support that the Sensorica network has provided to this project, we've also contributed with reflections, ideas on new business models, on open source software, new economic models, and also organizational structures, methodologies of collaborative work, and governance for peer-to-peer networks. Anyway, so Breathing Games is one of these communities. If you go to the new Sensorica website and look at communities, it appears there as one of these communities that interfaces with other communities within the Sensorica larger open network, right? So let's go back to this particular initiative here. If you go to the page and check the current initiative tab, you will have more information about what we're currently doing. It is about making 5 prototypes of the Model B of Breathing Games pressure sensor to be used at Saint Justine Children's Hospital in Montreal by researcher for clinical, well, not clinical studies, but let's say some pilot projects with actual patients, young kids that suffer from cystic fibrosis. So this is about a pressure sensor. It is about a hardware device. I'm gonna go over it and explain. The component is very, very basic, very simple. You see how fast you can prototype today using 3D printing and a few open source friendly electronic components and microcontroller board. This particular device, the kids that have respiratory problems, while they do their therapy at home, which is at least an hour a day, blowing into some boring devices, well, now they're blowing into this tube here, into this device that registers the pressure through this particular sensor, sends the pressure through to a microcontroller that also has Bluetooth on it, and then you can get the data to a mobile device or to a computer via the Bluetooth or through the cable, USB cable here, and you can connect that data to a game, so you make this therapy fun. If you go back to the website, you'll see these videos and more information about how these devices will be used by kids, helping them to make therapy fun. Not only that, but also when you think about gathering all this data about the therapy and sharing it to the doctor, it improves the chances of these kids for living a longer and more healthier life. Another thing here is that this particular device is completely open source. Anybody with living with this condition of cystic fibrosis that wants to make therapy fun can get the file, 3D print the casing, buy these devices. The whole thing might cost maybe $100. Go to the local 3D, go to the local Fab Lab or makerspace and ask these people that if you don't have the technical skills to put it together for you. It is very simply and cheaply done. Anybody with very low technical skills can put it together, order the parts and put it together. It doesn't require much. So that is the goal. Make it open source, make it low cost, and make it possible to be locally assembled, manufactured, so that any girl or boy living with cystic fibrosis can have it with under $100. Okay, so this is a pressure sensor, differential pressure sensor that is amplified on the chip, takes in 5 volts, and there's a bit of very basic electronic components here to dress it up, to make the signal a little bit more clean. This is a Adafruit feather with Bluetooth integrated in it. It runs on 3.3 volts. We feed it 5 volts from the USB pin. It is made to be fed 5 volts from USBs, charger, and computers, devices. And then it goes through a regulator that produces the 3.3 volt at which the board runs. So we feed it 5 volts because the sensor requires 5 volts. And then we use a voltage divider here to step down and rescale the voltage that comes out of the device, 0 to 5 volts, into 0 and 3.3 volts. Very simple trick, use 2 resistors. So this is a tube here from the pressure device that goes outside, and you connect it to the normal therapeutical devices that these kids use. All right, and so now it's connected through the USB cable to the computer, and let's see what happens when I'm running the data on screen. So I'm just going to get the tube here. This is the other end of the tube, and I'm just going to blow on it. There we go. I don't have to go too hard. And let's see where the signal saturates. There we go. This is the maximum value we can get. Have to blow really hard. With a moderate pressure, this is what we can do. There you go. So what we're seeing here is data that is gathered directly through the USB cable. Again, since this device has Bluetooth, you can get that data via Bluetooth to a mobile device or a computer device connected to any connected to a game that have been specially designed for breathing games. So now the kids that are doing the therapy at home, they can actually make it fun and have their data saved somehow. So it becomes easier for their doctors to follow the therapy. Here we go. So again, don't forget the Breathing Games website on Sensorica, the Breathing Games community. And why not joining the project? I think this is a great cause. Helping kids and making therapy more fun, producing open source devices that can be locally manufactured, locally assembled in any Fab Lab and makerspace out there under $100. Join the project. If you know somebody with cystic fibrosis, please tell him to contact our community, and we'll put him in communication, in contact with the project. Thanks for watching.